In this video, we will learn how to frame a steel floor, as well as create floor panels. For training purposes, we will frame the first level floor and panelize the second level floor. Let's start with the main floor. Go to the first level deck layout, go up to our drawing model pairs, and select first level deck layout. Before we start working with our floor framing, we need to set up our wall references. Currently, the main floor level walls are referenced. If we want to see our lower bearing walls or basement walls, we will need to add a reference drawing for our basement level. We'll go up to Reference Drawings. Select Properties to view which reference drawings are available. Click on Properties. The reference drawing for the first level walls is enabled. This is a reference drawing currently on screen. We'll need to add a reference drawing for our basement walls. I'll hit Cancel. Go back to Reference Drawings. From the menu, select Quick Load Drawing Model Pair to add a new reference drawing. From the Drawing Model Pairs dialog, select Basement Wall Layout. Now you see that we have both our main floor walls and our basement walls visible. We can leave both walls visible, or we can turn off the main floor walls. To turn off the main floor walls, go to Reference Drawings, Properties, and now you see we have two reference drawings, the basement walls and the first walls. Uncheck the first walls and select OK. I'll work with both reference drawings active, so I'll go back to Reference Drawings, Properties, and check the box for first walls. Having both active at the same time will help to ensure that objects are lined up properly. Similar to walls, floors also have framing tools. If you recall from the wall training video, walls have framing tools for setting framing parameters such as framing materials, spacing of framing members, framing details, and various other parameters. To access the framing tools, select a floor. When you select a floor, you'll see a new Plane Structure ribbon menu appear. You can access framing tools from the menu, or you can right-click, and from the context menu, you can also select framing tools. You have a type, which is a frame. You have your tool library, and the framing tool assigned to the floor. The floor framing parameters were assigned in the 3D levels. There are some additional tabs in the steel version. We have Tracks and Studs, Frame General, Direction and Alignment, and Insulation. Under Tracks and Studs, you can assign the spacing, different profiles for the joist, the header channel, header track, box profiles, and other profiles such as blocking and flat bracing. To change the profile, go over to the right to the Select button. In the Piece Properties window, under Cross Sections, you can select a different cross-section library. You can select a different profile size and a grade. In this case, for the steel, we have a 33 KSI or a 50 KSI. I'll select Cancel. Under General Framing, you can select the joist detail. Basically, this is a different configuration for your joist. If you hit Select, select a standard joist, a double joist, or a compound joist. You can set to mirror a joist. You can mirror all of them, every second one, or right side. There's also a setting for blocking detail. If you hit Select, you have different floor blocking selections: continuous blocking, staggered blocking, flat strip bracing on the top side, or flat strip bracing both sides. There is a Direction and Alignment tab for adjusting the direction of the joist, as well as an Insulation tab for adding insulation. We will leave the settings as is. We'll edit the direction and alignment using the Fields tool. I'll select Cancel to close the window. Just to refresh your memory where the 2x12 floor framing came from, when we first set up this project, we went into 3D levels. For the first and second floor levels, we changed the floors to a 12-inch deep floor framing. That's where the 12-inch deep floor framing was assigned to the project. I'll select Cancel to close out this window. If you plan on providing a sheathing layout or want to see the sheathing panels in the model, the floor layers must be unpacked. If you do not care to see the sheathing panels in the model, then pack the floor layers. Note that the sheathing is not removed. It is hidden and will still be included when generating materials lists. To expand or pack your floor volume, first select your floor volume. Under the Plane Structure menu, go over to the left. Under Volume, you have Expand and Pack. If you set your volume to expand, and we generate our parts, you'll see the floor sheathing included with your framing. If we go to 3D and switch it over to framing, the floor sheathing will be added to your model. I'll go back to 2D. I'll remove the framing. And this time, with my floor area selected, I'll select Pack instead. And now when I go to generate my framing, the floor sheathing is not part of the framing. And if we go to 3D, the floor framing is generated without the floor sheathing. So go back to 2D. And to delete your framing, select your area, and up under framing, go to remove. Now I'll generate the framing one more time with it expanded. Now if you have the sheathing visible, but need to temporarily hide it, you can select one of the pieces of sheathing, Control A to select all, and hit H to hide. It's still there, it's just hidden. To return it, you can right-click, Restore Hidden. There are several ways that you can do this in 3D. Let's go to 3D. Similar to the filter method, you can select a piece of sheathing, Control A, H to hide, or right-click and I'll restore it, or go to the lower left corner and select the model browser. We're working on the first floor, so we'll find the first floor level, select our plane structures, locate the steel floor framing, and expand the branch. Next, select the sheathing branch. Right-click and select Hide. To restore, right-click on the 3D view and select Restore Hidden in the menu. I'm going to go back to my architectural view and hit F2 to go back to 2D. Now I'll go back and remove my framing. One thing to be aware of when working with expanded layers is that you may be selecting the wrong layer. You click on the floor finish layer instead of the floor framing layer or volume. A way to determine if the correct layer was selected is to select a layer. If you pick the floor framing layer or floor volume under the plane structure menu, the fields and edge tools are shown in the edit framing section. If you select a different layer, like a floor finish layer, it will look something like this and have more grip points. This is indicating our selection of the hardwood floor layer that we added earlier in this model. When you look at the framing menu, the field and edge tools are not available, indicating that you did not select the floor framing layer. If you select the wrong layer, continue selecting layers until you pick the correct one. Hit Escape to cancel that selection. Before we generate our floor framing, we need to determine the direction of the floor joists and how they will be supported. We'll have the joists run front to back. Over in this area, we'll have them run left to right. For support beams, we'll add a drop beam over the family room. We'll add a flush beam to support the floor joists along this wall. We have 3 columns in the basement that will support that member. To adjust the framing for a floor volume, we'll need to work with the Field tool. To access the Field tool, select your floor area, and under the Plane Structure menu, under Framing, click on Fields. On the screen you will see a origin marker, indicated by an arrow, and you also see the word Field in red. This indicates that there's one field controlled by this origin marker. Now if we select the origin marker, and right-click, we can adjust some properties. We can move the origin marker. We can also generate the framing for that specific field. We can make a few changes to the framing by accessing the Properties tool. In the Framing Fields property, the default material will be steel material. We have a default material of 1200 S200-54. To change the default material for the joist, select Default, select your section library, and select your profile size. In this case, we'll leave it as the default. Cancel. You can change the on-center spacing for the floor joist. Let's change the spacing to 16 inches on center. And select OK. The origin marker indicates the start location of the joist run. Currently, it's starting on the left side of the structure. If we want to move it over to the right side, select the origin marker and select the grip point, and you can move it over to any point along the right side of the structure. I'll select the lower right corner. Disregard the change in the hatch pattern. The hatch pattern is used to represent the floor volume. It does not indicate the direction of the floor joist. You can also modify the joist direction by selecting the marker, click on the grip point, and right-click, and you have several options. You can change it to vertical, horizontal, back to default. You can also select a specific direction. We'll click Select Direction. We'll pick 2 points to obtain the angle that we want. Click 1 point, and let's just pick this point. The origin marker updates to match the angle that was set. Right-click, set it back to vertical. I'll just move it back to the left side. If we were to frame the floor, our joist would run from front to back. But in this exercise, we want to change the joist direction from left to right over in the family area. To do that, we'll select the origin marker, right-click, and we want to add a split. We can add a split by a line or by a polyline. We'll use polyline to create this split. A split line is a tool for creating fields within a floor volume. Fields allow the user to control properties for that specific floor area. We will change the joist to run horizontally in the new field, while the rest of the joist will run vertically in the original field. When adding a split line, the start point must be located on an outside volume edge or corner. The end point must also be located on an outside edge or corner. This split will be very simple. We'll start from this corner and run it across horizontally. The difference between the steel version from the wood version is there are no framing details assigned to the split line. Just go ahead and select OK. We have a red line for the split line and 2 offset lines indicating that we have 2 fields. When you zoom out, you'll see the word field in this area and the word field in this area, as well as 2 origin markers. We have the original one that's controlling this area. We have a second one in this area. Once you create a field, there's always an origin marker that's associated with it. To change the joist direction for this area, we'll just select the origin marker, click on the marker. We'll hit one of the arrows, left or right, or you can right-click like I previously had shown you. We'll hit horizontal. And it doesn't matter if the arrow is facing left or right, as long as it's horizontal. Pick that point. We have joist running vertical in this area and horizontal in this area. And this is also a way where you can control the different on-center spacing for different areas. So if we wanted to reduce the spacing or increase the spacing, you can right-click, Properties, and we can adjust the spacing for just this area. I'll leave it as is, and we'll hit Escape. Let's go ahead and generate the framing. Select the area, and go up to the plane structure and select Generate Parts. Now we have our sheathing also included, meaning that we've expanded our floor volume. And you see the joist direction change. These joists are running horizontal, and these are running vertical. Let's go ahead and remove our framing and add our support members next. With the floor selected, go up to remove, and it removes the framing. We need to add a support member along here to support the joist ends. To add support members and blocking to the floor, we need to work with framing lines. To access the framing lines, with your floor volume selected, go up to Framing, select the More button under the Framing menu, and you'll see Lines for Edit Framing Lines. Click on Lines. Framing lines are shown in red and have an hourglass shaped symbol. In this case, we have a framing line for the split line that we added. We'll zoom out. We'll add a support member over the family room. To access the framing line tools, right-click, and you'll see several options. We can add a cut line, which can also be used for adding a flush member. There's also Add Support Line for adding support members underneath the floor system. We also have blocking and ladders. Since we want to add a drop beam, we're going to select Add Support Line. To add our support member, we need to select 2 points. We'll zoom in, add the beam centered on the wall. Select the center line. We'll Q off that point, hit U to lock it in the horizontal. Want the member to start along the edge of this wall. And hit the U key to lock it in the horizontal. And we will run it perpendicular to this edge. In the description field, we'll select the drop down. The detail options in the steel version are different from the wood version. We have a selectable drop beam, a selectable drop beam back-to-back C+C, or selectable drop beam box C+U. We're just going to add a drop beam. And we'll select the parameters to select our beam. You can hit the select button to select a different member. In the piece properties window, we can select the library to select from. We'll select steel for a wide flange steel member. And under code, we can select the size or profile. I'll select the W10 by 26 and select OK. And select OK to close this window. And again, we get the line for the steel beam and also for the split line that we previously added. If we want to edit this member, we can just click on that framing line, right-click, and go back into Properties, hit Parameters, and we can change it to a different type of member. Hit Cancel, because that's the size we want. You can zoom out. Now we're still in the Edit Framing Lines, so we want to add a flush member next. We'll right-click, and this is a cut line, because it's going to cut the joists. So we'll add cut line. And we need to add our line indicating the location of the member or our cut lines. So we'll find the center line of this wall, hit Q over that point, hit U key, and we'll to reference that point and come over to that edge. And now we'll lock it in the horizontal and go all the way to the opposite side. And click on the floor edge. In the framing detail window, we'll select the description drop-down. We have different detail options in the steel version. We have a cut line with the back-to-back C, cut line with the back-to-back U, cut line with UC plus UU, cut line with blocking, and cut line without blocking. We want to add a flush member, so we'll add the cut line back-to-back C. There are no parameters to change, so we'll select OK. Now we have our flush beam. To edit the beam, select the line symbol, right-click, and you go into Properties. And then you can go back to the drop-down and select a different detail. Hit Cancel, and Cancel. Let's go ahead and generate our framing. Select the floor, and go up to Generate Parts under the Plane Structure menu. We have our joists, and we also have the sheathing applied. To view the model in 3D, you can select the F2 key, or you can go up to the switch between 2D and 3D. We'll change it from architectural view to framing model. You can see we have the sheathing and our framing. Let's use filtering to hide the sheathing. So we'll select a piece of sheathing and Control A and select the H key to hide the sheathing. We can rotate this around. You can see our drop steel beam, our flush beam, our joists that are running horizontal, and our joists that are running front to back. Now these joists are cut by that flush member, so if we select one of the joists, you see that our endpoints stop at that flush member. Hit Escape and F2 to go back to the 2D view. Next, let's add some blocking to the floor framing. With the floor selected, go up to Framing, select Lines, right-click, and select Add Blockings. Let's add blocking over this beam. We'll select the center line of this beam, select U key to lock it in horizontal, select the inside edge of this joist. Now in our framing detail window under Description, we have continuous blocking, solid blocking inline, selectable, and staggered. We will use continuous blocking. Continuous blocking will insert a single continuous piece of material with holes cut out for the joist to extend through the blocking. Select OK. There are no parameters, so we'll just continue with OK. Now if we go to 3D, hit the F2 key, go into Framing Model. We'll filter out the sheathing, so we'll select a piece of sheathing. Select Control A and the H key to hide. Zoom in and we see that we have a continuous piece of blocking. Go back to 2D, so hit the F2 key. Now let's add some ladder framing. Let's go back to this back wall. We'll add some ladder framing in this bay. Select our floor. Go up to Framing, Lines, right-click, and select Add Ladders. We'll select an inside edge of this joist, run it horizontal. We'll select the inside edge on the opposite side. In the Description drop-down field, the only option is ladder blocking. So we'll just hit OK. We can change the spacing of the ladder blocking. Go into Parameters, select the drop-down, and change the on-center spacing. Let's go to 24 inches. Select OK, and OK. We have our ladders and our ladder line. Now it is always a good idea to generate our parts, because you'll notice that on one side we do have a swage connection, and then on the other side we do not. But if we regenerate this framing, we'll get the connection updated. To update our connection, we just need to go up to Generate Parts. Go up to Generate Parts. And the connections have been updated. Select Escape to cancel any selections or commands, and Shift-A to zoom extents. There are numerous connection details available in the library for connecting framing members. Go up to the Modeling tab, Connection, Joint, and Connection Details. In the browser, go to the Light Gauge Steel category. You can find area tools, connections for C to C, C to HR, C to U, fasteners, gusset plates, out of plane, and various tools. Let's go ahead and go to C to C. Here you'll find various connection details, from swage joints, to continuous joints, to reverse swage joints. Let's go ahead and add a swage joint. Double click. Let's zoom into the flush member, and we'll add some connections. We'll select our track, and select the piece ends. Just like in the wood version, we can go through and select each one individually, or we can select multiple ones by using a crossing window. Select these, select V to confirm. Now in this window, you can select the quantity of fasteners per side, your fastener, a connector. I'll just go with the 1 inch by 2 inch. The end shape, and various other options. I'll select OK. We'll delete the connecting part. Now if we zoom in, we can see this little red dot indicating that the connection has been added. Let's do the same on the opposite side. Select the track. Let's select the ends of these joists. V to confirm. Remembers our last setting, so we'll just select OK and delete. Adding holes is simple in Vertex. Let's add some holes to a few joists. We'll go back up to Connection, Joint, Connection Details. Under Light Gauge Steel, go to Tools. Let's go to Large Surface Holes. Double click. Now it's prompting us to select the pieces. We'll select these pieces and hit V to confirm. Next, we need to add a hole position. I'll find the midpoint of that joist. Now we only need to select that one position. The holes will get applied to the other joists. V to confirm. If we zoom in, we can see the hole outline in the joist. Let's view this in 3D, so hit the F2 key. Switch to the framing modeling view. Select your piece of sheathing. Control A, H to hide. If we zoom in, we can see the holes that have been added to the joists. If we zoom back out, we can see our swage connections. Let's go back to 2D, select the F2 key, Shift A to zoom extents. Let's save the project. Go to File, Save Project. We've completed our framing for this floor, but I do want to cover how we can add additional materials or profiles to this floor. To add profiles, select your floor. Under the Plane Structure Framing menu, we have Add Profile. There are several options for adding a profile. We can add a profile or joist in any direction. We can also copy an existing profile or joist. We can add a primary beam. Or we can add a profile that's linked to any plane on this structure. Let's go to the top of the menu and select Add Profile. Under the cross-section area, we can select the cross-section and select any one of these types of profiles. Under the Code drop-down, we can select the size or profile. Under Classifying Data, we can select the use, if it's a joist or a beam, and its function, if it's a header, side member, opening member, blocking ladder. We'll just leave it as a default as joist. You can also set the location of the profile, if it's flush to the top, flush to the bottom, or dropped. We'll leave it at flush top. Now, if we want to add a profile that matches a member that's already existing in our framing, we can select the Pick button at the lower left corner. Select the framing member. I'll select an existing joist. Now our cross section is updated to match those properties. Let's go ahead and select OK. And I'm just going to draw a member in between these joists. Here's our new profile. Let's add another profile. This time we'll select the second option from the menu, Add Profile. Use this option to copy an existing floor joist. Select Add Profile. It's prompting us to select a point. Let's add a joist in between these two. Now you notice that it didn't prompt us for a piece or a type. It inserts a joist that matches our default framing. Next, we need to select our length. Do we want it to extend just to the field or through the area? If piece line length is set to field, then the joist only extends to the nearest split line and flush member. If through area is set, the joists ignore the flush members and extend through the entire area. We'll leave it at field and select OK. Next, under the framing detail, we can change the type of detail, various flat bracing options or joist options. We'll leave it at joist. Select OK. There are no parameters available for this detail. If we want to mirror this joist, we can check the mirror box. Leave it checked to have it permanent or part of the framing. And select OK. And it adds a joist to our framing. There's another profile that we can add. There's a primary beam. The difference between the primary beam and the other two options, the primary beam is not connected to the floor framing. So if you were to regenerate the floor framing, your primary beam is not affected if the floor is regenerated. Select Add Primary Beam. Again, you can go to the cross section, select the library. I'll leave it at steel. And I'll just select a different size. It doesn't really matter, so I'll select a W6 by 12. We can set the use, beam, joist, or rafter. I'll leave it at beam. And we can also set the function. I'm going to change this to a main beam. We can select the location, flush top, flush bottom, or dropped. I'm going to set this one to dropped. Now select OK. I'm just going to draw the beam from right to left. Again, this isn't part of our framing, just for training purposes, so it doesn't really matter where I place this. The primary beam is indicated by the red dashed lines. There's also another tool for adding profiles. The fourth option down, Add Profile, allows you to add a profile to any plane in this structure or project. So if we select Add Profile, again, similar options. Let's match our floor joist. So I'll select Pick and pick one of the joists. And I'll select OK. When adding the profile, you can select the locating point. You can select from the 9 locating points in the dialog. The locating points are used for adjusting the profile when adding it to the model. I'll leave it as is. Start from the left side. Lock it in a horizontal direction with the U key, and then select the inside edge of the rim. Hit Escape to cancel the command. Let's take a look at these objects in 3D. So hit the F2 key. Switch to the framing view. And let's hide the sheathing again. This time I'll use the modeling tab to hide our sheathing. Go down to the lower left corner, model tab. We're working with the first floor. Expand it. Expand the planar structures. Come down to sheathing. Right click and select hide. If we rotate this around, you can see the additional profiles. And you'll notice this profile is not in plane with our floor framing. This profile was added using the profile tool that applies a profile to any structure plane. It may not line up exactly as you intended. To adjust the location of this profile, select the profile, right-click, and select Edit Heights. The 3D level for this profile is set to First Floor. First Floor is the top of our floor framing, which also includes our sheathing. We have an offset value of 0, And the reference point of the joist is set to center, explaining why the middle of the joist is in line with our top of our floor. Change the center to top and select OK. You can see the profile has shifted down further into the floor framing, but it is still extending above the floor framing. The reason for this is that it's actually at the very top of our floor framing, which again includes our floor sheathing. So we'll need to select our joist, right-click, edit profiles, and we need to add an offset to account for the floor sheathing. So we'll add a negative 3/4 inch for our 3/4 inch floor sheathing. So now it will line up with the top of our floor framing, minus the 3/4 inch for the sheathing, and that's the top of the joist. Select OK. And now you see that it is in line with our top of our floor framing. Using the fourth option under Add Profile can require more work when aligning the profile to the floor plane. This option can apply a profile to any plane in the structure, which requires more adjustments in order to line up the profile to the plane. Hit the F2 key to go back to 2D, and Shift A to zoom out. Any of these profiles or framing members can be modified. If you select a member, you get a middle grip point and 2 endpoints. Select the endpoint. You can extend or shorten the length of a profile. Let's shorten this joist back. Click that point, and yes, we want to remove the present joints. You can select the middle grip point to move the profile. I'll lock it in vertical and just shift it up a few inches. You can change the profile properties by double-clicking on the member. Maybe we want to change this cross-section to something different. Let's go with a wide flange steel beam. And we'll just pick a W10x12 and select OK. You can modify any piece in the framing just by double-clicking. Or you can right-click and select Properties. One thing to be aware of if you made manual edits to your floor framing, when you select Generate Parts, your framing will go back to its default state. Once you start making manual edits to your floor framing, it's best to avoid using Generate Parts. Since we've made some of these changes manually, so if I select a floor, select Generate Parts, Vertex refreshes our framing back to its default state. And you see the changes that we recently made are no longer there. If I zoom out, you'll see that some of the joists that we added are also gone, except for the main support beam and the joist that was copied using the Add Profile second option. Profiles added using the first and fourth option are removed anytime you generate framing. If you use the second and third option, those will not be affected by regenerating your framing. Since I previously saved my project before making these changes, I'm going to go up to File, Open Project, and no, I do not want to save these changes, and select my project from the previous state. Go back to the first floor framing layout. Now that the floor framing has been completed, the next step is to add a material schedule and labels to the materials. Since we are working with an unpacked floor, let's add labels to our floor sheets. Go to the Output tab. Next to Profiles, there's Sheet Schedule. Click on Sheet Schedule. In the Sheet Schedule parameters, we can add labels, a material schedule, and drawings. You can also remove these existing items if you have previously labeled your sheets. Select Remove for each one of these items. In this case, we're adding them, so let's make sure we have Add. Under Labels, we have New Location or Current Location. Leave it set to New Location. Vertex will add the labels in the default location. This is typically the center of the sheet. We have the System. The system is the label style. In this case, we have S as a prefix, followed by a number for the sheet. For schedule, we'll have it Add a Schedule. If you want to include drawings for any special cut sheets, check the Drawings box. Set it to ignore any full sheets or rectangular sheets. And if you have previously created sheets, it will delete the old sheets if this is checked. Select OK. Now you will see that the labels have been added to the center of the sheets, and the schedule is now linked to your cursor. Select a point to add the schedule. Now if we zoom in on the schedule, you'll see the label, the quantity, the material of the sheet, description, basically it's the size of the sheet, and the area. So if we zoom out, you can see that each sheet has a label assigned to it. We also check the drawing box for Vertex to create any drawings for sheets with irregular cuts. Go over to the project document browser on the left side, expand structural sheets, sheet drawings, and you see that it created 3 drawings. One for S4, S5, and S8. Let's go ahead and open S4. And here's the cut sheet. The drawing shows how this sheet needs to be cut. Close out. Go to sheet 5. Similar type of cut, just on the opposite direction. And then sheet 8. And sheet 8 has a couple of additional cuts. If we zoom in on the drawing, we can locate where those sheets are. So there's sheet 8. If you click on it, you can see the shape or the outline of the sheet. And the others are around the stairwell. So we have sheet 5 and sheet 4. Again, it only creates drawings for sheets with irregular cuts. Anything that's rectangular or full sheets will not have drawings. To remove the schedule and labels, go back to Output. Again, select Sheet Schedule. Select Remove for each of these items. We'll keep the sheet labels and schedule, so select Cancel. Next, let's add the joist labels. So again, we'll go up to Output tab. This time under Profiles, we'll select Schedule. In the Select dialog, you have different materials that you can create schedules for. We have floor joists with group labels. The difference between these two options, floor joists will label each individual joist. Floor joist group labels will create a group label for similar length joists. And there are also various other materials that we can create schedules for. Let's go ahead and select floor joist group labels. Next, we get a piece schedule parameters similar to the sheet parameters. Again, you can add or remove labels, the schedule, and drawings. We'll leave the label location set to base. We'll have it check overlapping labels. And we'll just have it check all the labels and refresh them all. System is the labeling system it's using. We'll leave it at the default. Presentation is the label macro or the label style. Under schedule, we have macro. Macro is the schedule style or layout assigned to the material schedule. The format is the material that it's creating the schedule for. In this case, we have floor joists. And the presentation is the label that's being applied to the joist itself. So it's using a piece.schedule label. For drawings, we won't have it add drawings for each individual joist. If you do want it to have drawings for any specialty cut joists, you can have it create drawings for any joists that do not have perpendicular cuts or notches. We'll leave this unchecked. We'll select OK. Similar to adding a sheet schedule, we have a schedule linked to our cursor. Select a point to add the sheet to the drawing. Now if we zoom in on the schedule, you'll see that it says floor joist schedule, our piece ID, quantity, the material, the application description, the length, and any angle cuts on each end. Zoom back out and let's look at the drawing. If we zoom over, you can move the label by clicking on the label. Click on the grip point. Lock it in a vertical. You can move the label down. Hit escape when you're done. and then hit Zoom Extents, or Shift A. Now in this case we have both our floor framing and our sheathing. Now if we wanted to make a drawing for each one of these, when we get to the point of actually creating a PDF or a drawing, we could assign a layering style or a layer group. We can use this level to create two separate drawings, basically by controlling the layer group. Just to give you an example, go over to the floating toolbar. Mine's over on the right side, yours may be on top. And I'm going to select layers from list. Now when we get to the point where we're actually going to plot a drawing or create our sheets, all we need to do is change our group for this sheet. So if we scroll down and go to Plot Floor Frame, click on the light bulb. By selecting the Plot Floor Frame, you'll see that our drawing has changed and only layers that pertain to floor framing are visible. This includes our schedule and our labels. Now if we go back to the Layer Group window and select Plot Floor Sheathing, now only objects that pertain to the sheathing layout are visible. It turns off the labels for the joists and schedules for the joists, but it retains the sheet schedule. By using plot groups, you can create different drawings from one layout. Let's go back to the floating toolbar and select Restore Default Layers. And switch back to the second level deck layout. Panelizing floors in the steel version works the same way as it does in the wood version, other than the materials that you're working with are different, and also the connection details are different. Before we panelize the floors, let's set up our reference drawings. We need to add the reference drawings for the lower floor so that we can see all our support locations. Let's go up to Reference Drawings, down to Properties. You should see our second level walls and our first level walls. If you do not have the first level walls, hit Cancel, go to Reference Drawings, Quick Loaded Model Pair, and select First Level Wall Layout to add the reference drawing. I'll hit Escape, go back to Reference Drawings, down to Properties. I'll turn off the second level walls and turn on the first level walls. Select OK. Now that we have our lower walls visible, we can see our bearing locations. The center wall will serve as our middle bearing point, and we'll add a beam at the back end to support the panels. Select the floor. Under the Plane Structure tab, under Framing, select the More button, and select Lines. Right-click, and we're going to add a support line. This will be our drop beam. We'll zoom into this corner. We'll locate the center line so we can center the beam. Select Q to set that reference point. Select the U key to lock it in horizontal. And we want the end of that beam in line with the framing of this wall. So we'll select that point. Hit the U key again to lock it in horizontal. Bring it across and snap to the floor edge. In the framing detail, we'll select the drop down and we'll select Selectable Drop Beam. We'll go to Parameters and let's select a different steel beam. Under Piece Selection, click on the Select button. Under the Cross Section Library, select Steel. And under Code, select the W8 by 18. And select OK. And select OK under the Piece Selection. And select OK one more time. Now we have a drop beam to support our floor panels. And select Shift A to zoom all. Select the Escape key to exit out of the command. Next we need to review our framing tool for our floor. Select the floor. With the floor volume selected, right-click and select Framing Tools. In the Framing Tools, we're using the Floor Structures tool library. When we first set up this project, under 3D levels, we assigned the 1200 S200-54 joist material. Under the Frame Tracks and Studs tab, let's change the spacing to 60 inches on center. Our frame thickness is 12 inches. And we'll leave our main, box, and other profiles as is. However, if you need to change a profile for any one of these components, click on the Select button. Under the Libraries, you can select a different material type. And under the code, you can select a different profile. We'll leave it as is and select Cancel. Next, under the Frame General tab, we can select the joist detail, hit the Select button, and you can change the joist to a standard joist, a double joist, or a compound joist. We'll leave it at standard. We'll leave the mirror to no mirror, and leave the blocking detail at default. But to change the blocking detail, you can hit the Select button, and change the different blocking types from continuous blocking, staggered blocking, flat strip, top side, flat strip, both sides. I'll close out of this box. Under the Direction and Alignment tab, we'll leave those settings as is. We'll make any changes using the origin marker. And we'll leave the Installation tab as is. Select OK to apply our changes. Next, let's add our panel breaks. With the floor selected, go up to the Plane Structure tab, over to Panel Break. The cursor has been updated to show the direction of the panel break. Right mouse click to access the panel break tools. We have Add Panel Break to an area, that will add a single panel break. Add panel breaks to an area, use this tool to add multiple panel breaks. You can add panel breaks to a field, so once we add a panel break, we can nest another break within a field. And we can also add multiple panel breaks to a field. We have spacing, the quantity, and the seam width. You can set seam detail 1, seam detail 2. You have parameter sets, and you have the full cut, pick cut toggle. When the toggle is switched off, the panel break lines are trimmed to the edges of the area closest to your pick point. With the toggle switched on, the panel break lines will extend through the entire area. Select Add Panel Breaks to add multiple panel breaks. Go up to Spacing. Click on Spacing. And let's change that to 10 feet, so 120 inches. Right click again. Let's go to Quantity. Set that to 4 panel breaks. Right click again, and let's set the seam width. Let's add a gap of about 1/4 of an inch. Type in 0.25, select OK. We'll leave all the other settings as is. Zoom into the lower left corner to set our base point. The panels will offset from this point over to the right, 10 feet. Zoom out. Now we have our 4 panel sections. The red lines indicate our panel breaks. Now select the floor area. Go up to Plane Structure, Generate Panels. Now that we've established our 4 panels, we can generate the panels one at a time by clicking the panel label, or we can select all the panels at one time with the crossing window. We'll draw a crossing window around the 4 panel labels to select the panels. Right-click and confirm Build Panel based on current layers is set. Select OK. Under the Panel Build dialog, our numbering is set to 2F for second floor, and it's going to start with the number 1. The structure is set to Floor Panel Common, and the use is set to Floor Panel. Now for the structure, we can set some parameters, so click on Parameters. We want it to generate our framing, and we want the joist to run on the longest span. There's the shortest span, longest span, and use the defaults. We'll switch it to longest span, and we'll generate the sheathing as well. Select OK. And we'll uncheck Remove Panel Breaks. If you need to make any edits to the panels, having the panel breaks makes it easier to make the adjustments. And select OK. Vertex then goes through and generates the panels. And it labels each of the panels and adds the sheathing. So if we zoom into this label, we have this second floor, 2F, panel number 2. And there's an asterisk beside the label. The asterisk indicates that a drawing has not been created for the panel. After we create the drawing, the asterisk will disappear. Zoom out. Let's add blocking along this bearing wall. When adding blocking, we need to add blocking in each individual panel. So let's start with the one on the right. We'll need to select the panel, continue clicking on the hatch pattern until only the floor area for this panel is highlighted. Next, go up to Panel, select the More button to expand that window, and select Lines. Right-click, and let's add a blocking line. Come down to Add Blockings. Zoom in, and let's start with the end point here, since we can't find an exact point along the inside edge of this joist. We'll cue off the centerline end, hit the U key, and now select the edge of that joist. Select the U key to lock it in horizontal again. And we need to stay inside this floor panel, so we'll make sure we don't exceed past our seam. We'll go up against this joist, which is our last joist of that floor panel. Click on the edge. Now we get the framing detail dialog. Under description, we can select the drop-down field, and we can select the different detail for our blocking. We got continuous blocking, solid blocking inline, solid blocking selectable, or staggered. We'll go with continuous blocking. There are no parameters for this detail, so we'll just select OK. And you can see it adds our blocking and our blocking line. Let's add blocking to the next panel. This time we'll add blocking from this edge over to the double joist. We'll go from the double joist to the last joist of that panel. So hit Escape to clear our selection. Now we need to highlight this panel. Click on the panel label to select the panel. Go back up to Framing, expand the More button, select Lines again. Right-click, Add Blockings. Cue up that endpoint, since we don't have a snap point along this edge. So we'll find the center line, hit Q, the U key to lock it in horizontal, and click on the edge of the joist. Lock it in horizontal again, and select the edge of the double joist. Under Framing Detail, it remembers our last settings, so select OK. Since we're still in the same panel, we'll just right-click, Add Blockings. Select the S hotkey to find the intersection of the wall centerline and the joist edge. And then hit U key to lock in the horizontal and butt up against this joist. Select OK in the Framing Details dialog. Zoom out, and let's do the exact same thing for these last two panels. Select this panel, go up to Framing, Lines, right-click, Add Blocking. Select Q to set the reference point, hit U key to lock it in the horizontal, and select the edge of this joist. U key to lock in the horizontal again, go all the way across to the edge of this last joist in that panel, and select OK. Hit Escape to clear out our selection, and select the last panel on the left. Go back up to Framing, select More, click on Lines, right-click again, and select Blocking. Should have an intersection there, so we can hit the S key to find the intersection. Lock in the horizontal with the U key, and butt up against the inside edge of this last joist, and select OK. Now if we zoom in on the blocking, we don't actually have a connection made there. Right now we've just got the blocking going through the joist. We need to refresh this framing so we can get a connection generated for each location where our blocking and joists meet. Zoom out, keep your finger on the Control key, and select each of the panel labels. You can right-click, select Generate Parts, or you can select Generate Parts from the top menu. It'll go through, generate the parts, and if we zoom in, you'll see we get the little red X, and now we have a connection at each joist and blocking intersection. Hit Escape to clear our selection, Let's take a look at this in 3D. So hit the F2 key, change to the framing model. And now you see we have two floors, our main floor and our upper floor. Let's hide the sheathing. So pick a piece of sheathing. Select Control A to select all the sheathing and H to hide. Now if we rotate around, you can see that we have our steel member that we added. And if we zoom in on our blocking, you can see our connection now between the joist that's running through the blocking and the continuous blocking. And if we zoom in between the two panels, you'll see the gap that was assigned in the framing tool. Let's go back to 2D. Let's go back to architectural model and hit the F2 key to go back to 2D. Now let's create our panel drawings. So we'll go to Output. Under Panels and Trusses, select Panel Drawings. Over in the left-hand side, under Element Drawings, it lists all our panels. You'll see the ID and the drawing status. So our drawings are out of date or not created. So you can create each individual panel drawing by selecting a panel drawing, right-click and create, or we can highlight each one of them. Select the first one, keep your finger on the Shift key, and select the last one to highlight all four of them. Right-click, and let's hit Create. Under Panel Drawing Templates, under Floors, we'll select our floor panel drawing, since that's the only one we have, and we'll select OK. Now we can go through and open each of our panel drawings. To open a panel drawing, let's select floor panel 2F4 for second floor panel number 4. Right mouse click and select Open. There's our panel drawing with our blocking. You can also open a panel drawing by going to the ID. Once you select the ID, up on top of the menu, you should see Open Drawing. Click on Open Drawing and it'll open that specific drawing. You can expand it. You can see our blocking, see our piece list, our label, quantity, material, description, and the length. You can zoom in if you need to move some labels around. You can do that by just clicking on a label, selecting the grip point, and you can clean up any overlaps. Go ahead and hit Save to save that drawing if you make any changes, and hit the red X to close out. Select Shift-A to zoom all. You can also access the panel drawings from the Project Document Browser. Go over to Structural Drawings, expand that list. Under Floor Panels, you'll see each of the IDs. You can double-click and open the panel drawing from there. Select the X to close out. We can add a panel schedule to the drawing. So if we go up to Output, under Panel and Trusses, select Schedule. From the Select Panel schedule, you can create schedules for different types of panels. We're working with floor panels, so we'll select Floor Panels. And we'll add that to the drawing. If we zoom in, we have our floor panel schedule, our label, quantity, the code, which is a material, the width, the height, and the weight of each panel. Unlike the main floor framing, the material schedules are part of the panel drawings. We can print individual panel drawings. We select the label, right-click, and select Open Panel Drawing, or you can select it from the top ribbon. With the drawing open, we can go to File, Print, and the Print Drawing dialog, we'll select PDF. This was an 8.5 by 11, so we'll change the sheet size to ANSI A 8.5 by 11. We'll set the scale to fit the sheet, and we'll change this to a 90-degree rotation. Select the middle box to center it, and we'll select OK. Under the Save As, set the save location. Now it won't automatically open the PDF, so you'll need to use your file browser and search for it. Use your PDF viewer to view the drawing. You can also create a PDF book of the panel drawings. Go over to File, Export, to Edit PDF Sets. We scroll down, you'll see a Panels Floors PDF book. We'll use that to create a PDF set. Hit Cancel. Go to File, Export, Print PDF Sets. Select Panels Floors and select OK. Enter a file name. We'll leave it at the default name. Vertex collects the panel drawings and creates a PDF book of the drawings. After Vertex assembles the PDF booklet, it opens in your default PDF viewer. And we have a booklet with each of our panel drawings. Close out. Let's view our floor in 3D. So we'll hit the F2 key. We'll switch to our framing model. You can see that our upper floor has been panelized. There's seams at each of the panels. Let's go ahead and turn off the sheathing. Let's go over to the Model tab on the left. Go to Second Floor, Panels, Floor Panel. This is the 2F4, second floor panel number 4. Select the sheathing for this panel. Right mouse click and select Hide. You'll see that it only hides the sheathing for that specific panel. If we select a piece of sheathing, do Control A. Again, we can select all the sheathing and select H to hide. We can rotate. There's our panels with our seam. And there's our drop beam. Switch it back to the architectural model and select the F2 key to go back to 2D. That concludes our floor framing training. In the next video, we will cover wall framing.